matrices A and B, how would you find AB and BA? Remember, matrices are not commutative. A multiplied by B may or may not equal B multiplied by A. Let's find AB first. Before we multiply, we need to check if they are compatible or not. Only if they are compatible, we multiply them, else we can't. How did we check for the compatibility? We found the order of each matrix and checked if the second and the third numbers are equal. If yes, then they were compatible, else they were not. What is the order of the first matrix? It has 2 rows and 2 columns, 2 by 2. And what's the order of the second one? 2 rows and 3 columns, 2 by 3. The second and the third numbers are equal. It means that the number of columns of the first matrix is equal to the number of rows in the second. This tells us that the two matrices are compatible for multiplication. But as discussed in the previous session, we could have just counted the number of columns of the first matrix and compared it to the number of rows of the second. Why is it a better idea to find the orders of the matrices? It's because this also gives us the order of the resulting product. The first number is 2 and the fourth number is 3. This will be the order of the resulting product, 2 by 3. Now you know why finding the order of each is better. They not only tell us the compatibility, but also the order of the resulting product. We zoom out and find the product AB. We know that its order is 2 by 3, 2 rows and 3 columns. We need to find the elements in these 6 positions. Let me tell you the best way to multiply these two matrices. We take the first row of the first matrix and multiply it with each of the columns of the second matrix one by one. And then we do the same with the second row and so on. Solving it will give us a better idea. What will be the 1/1th element of the resulting product? It will be the first row of the first matrix multiplied by the first column of the second. It will be 1 times 1 plus 2 times 1. We multiply this number with this one and then this one with this. We have multiplied the first row with the first column. Now for the 1/2th element, we multiply the first row with the second column. We get 1 times 2 plus 2 times minus 1. This sum will be the 1/2th element. For the 1/3th element of the resulting product, we multiply the first row with the third column. We get 1 multiplied by 0 plus 2 multiplied by 3. We are done with the first row. We have multiplied it with each of the columns of the second matrix. There are 3 more elements we need to find. To find the element in the 2/1th position, we multiply the second row with the first column. We get minus 1 multiplied by 1 plus 0 multiplied by 1. Why don't you try finding the elements in these two positions? Pause the video and give it a shot. For the 2/2th element, we multiply the second row with the second column to get this. And for the 2/3th element, we multiply the second row with the third column to get this. It's quite easy to remember. 1/1th, first row, first column. 1/2th, first row, second column. 1/3th, first row, third column, and so on. This was the part we had to understand well. The rest is just plain simple calculation. Let's see what we get as the product. This will be 1 plus 2, 3. 2 plus minus 2 will be 0. 0 plus 6 will equal 6. Minus 1 plus 0 will equal minus 1. Minus 2 plus 0 will equal minus 2. And 0 plus 0 will equal 0. 2 rows, 3 columns. The order is 2 by 3, the first and the fourth number. Now let's try finding BA. Here B is the first matrix and A is the second one. Let's first see if they are compatible for multiplication. We find their orders. The order of B is 2 by 3 and the order of matrix A is 2 by 2. The second and the third numbers are not equal. Hence, these two matrices are not compatible for multiplication. What do we mean by the transpose of a matrix? To find the transpose of a matrix, we simply interchange its rows and columns. Yes, that gives us its transpose. Let's try out an example. This is matrix A. It has 2 rows and 2 columns. We need to find the transpose of this matrix. It is written as A with T as a superscript. What will this be equal to? We need to interchange the rows and columns. The first row becomes the first column. The first row is 1, 4. So the first column of the transpose will be 1, 4. The first row became the first column. And the second row of the matrix will become the second column of its transpose. The second row is -2, 3. So the second column of the transpose will be -2, 3. The rows of the matrix become the columns of its transpose. Or we can also say that the columns of the matrix become the rows of its transpose. Column 1 became row 1 and column 2 became row 2. But students often get confused at this point. So here's a good way to remember transpose. Assume that there are 4 cement bags, 2 on top of the other 2. The top 2 bags weigh 1 kilogram and 4 kilograms, and the bottom 2 weigh 2 kilograms and 3 kilograms. Let's say we put a box underneath it. If we push the first row, the 4 kilo bag will fall here. And on pushing the 1 kilo bag, it will land on the 4 kilo bag. Now let's push the bags in the second row towards the right. The 3 kilo bag will fall here and the 2 kilo bag will fall on top of it. This is the transpose of this matrix. The first row became the first column and the second row became the second column. So this was just one of the ways to understand transpose of a matrix. Okay, so here's matrix B. I want you to try finding the transpose of matrix B. So the first row will become the first column of the transpose. The first row is 1, 2, minus 1. 1, 2, minus 1 will be the first column of B transpose. The second row, 3, 0, 4, will become the second column of the transpose. 3, 0, 4. That's B transpose. The rows and the columns were interchanged. If we are using a cement bag approach, this is how it will look. The first row falls to become the first column, and the second row falls to become the second column. What is the order of matrix B? It has 2 rows and 3 columns. Its order will be 2 by 3. And B transpose has 3 rows and 2 columns. 3 by 2. The order is also reversed. 2 by 3 becomes 3 by 2. If the matrix is of order 3 by 4, then its transpose will be of the order 4 by 3. We will look at more examples over the next few sessions. In this video, we will learn something called a symmetric matrix. Yes, a symmetric matrix. When can we say that a matrix is symmetric? Matrix A is symmetric if A transpose is equal to A. Understand this well. The transpose of the matrix is equal to the matrix itself. This is the definition of a symmetric matrix. Look at this matrix A. Is it symmetric? What does the definition say? It will be symmetric only if its transpose is equal to itself. So what is A transpose here? We interchange the rows and columns. We get A transpose as 1, 2. The first row became the first column and the second row became the second column. Are they equal? When are two matrices equal? Do you remember equality of matrices? Two matrices are equal if they're of the same order and if their corresponding elements are equal. Here the orders are different. The order of A is 2 by 1 and that of A transpose is 1 by 2. They are not equal. Because A transpose is not equal to A, we say that A is not a symmetric matrix. That's how easy it is to find out if a matrix is symmetric or not. We find its transpose and check if it's equal to the original matrix. If not, then the matrix is not symmetric. Let's take another example. Here's matrix B. Is matrix B symmetric? Pause the video and find out if B is a symmetric matrix. To know if B is symmetric, we find B transpose first. The first row becomes the first column, 1, 4. The second row becomes the second column, -1, 2. And the third row becomes the third column, 0, 3. This is B transpose. Are B and B transpose equal? The order of B is 3 by 2 and that of B transpose is 2 by 3. As the orders are different, they are not equal, which means B is not a symmetric matrix. This should give us a hint. Tell me, can a rectangular matrix ever be symmetric? A rectangular matrix is a matrix in which the number of rows is not equal to the number of columns. Can it ever be symmetric? No chance, because the order of the transpose will definitely be different from that of the matrix. Only a square matrix can be symmetric. A square matrix is a matrix in which the number of rows is equal to the number of columns. Take matrix C for instance. 2 rows and 2 columns. This is a square matrix because its number of rows is equal to its number of columns. Is this a symmetric matrix? We find C transpose to know the answer. The first row becomes the first column, 1, 2, and the second row becomes the second column, 2, 4. Clearly the two matrices are equal. Same order and the corresponding elements are equal. 1 and 1, 2 and 2, 2 and 2, 4 and 4. Matrix C is a symmetric matrix as its transpose is equal to itself. Does this mean that every square matrix will be symmetric? Here's matrix D. It's a square matrix because its number of rows is equal to its number of columns. Pause the video and find out if matrix D is a symmetric matrix. To know if D is symmetric, we need to find D transpose first. The first row will be the first column here. 1, 3, 1. The second row becomes the second column. -1, 1, 4. And the third row will be the third column here. 2, 1, 0. Are these two matrices equal? The orders are equal, yes. But are the corresponding elements equal? Let's check. 1 is equal to 1. 3 is not equal to -1. For two matrices to be equal, all the corresponding elements must be equal. As 3 is not equal to -1, these two matrices are not equal. D is not a symmetric matrix and it is not equal to its transpose. So remember, every square matrix need not be symmetric, but for a matrix to be symmetric, it has to be a square. Like in the first two examples, the matrices were not square, so they will surely be non-symmetric. But if they are square, then they may or may not be symmetric. Here's one last example you need to solve. This is matrix E. Pause the video and find out if it's symmetric. The first thing we need to check is if the matrix is a square matrix. As it has equal number of rows and columns, we can say that it is a square matrix. So it may or may not be symmetric. To find out if it's symmetric, we need to find E transpose. This is what we get by interchanging the rows and columns of E. First row, first column, second row, second column, and third row, third column. Both matrices have the same orders and the corresponding elements are also equal. Matrix E is equal to E transpose. Matrix E is symmetric. With this, we can modify the original definition a bit. We say that a square matrix A is symmetric if A transpose is equal to A. This is a better way to understand it. If it's not square, we can directly say that it's not symmetric. And if it is square, we find A transpose and check if it's equal to matrix A. If it's equal, we say that the matrix is symmetric. In the previous session, we saw what a symmetric matrix is. A square matrix A is symmetric if A transpose is equal to A. In this session, we will look at what a skew-symmetric matrix is. The definition goes like this. A square matrix A is skew-symmetric if A transpose is equal to negative A. Let me repeat. A square matrix is skew-symmetric if its transpose is equal to its negative. A simple example would definitely help us understand better. Is this matrix A skew-symmetric? So we will find A transpose first and then negative of A. If they are equal, then we can say that matrix A is skew-symmetric. Let's find A transpose first. The first row becomes the first column, 1, 4, and the second row becomes the second column, 0, minus 1. This is A transpose. And what about negative A? To find the negative of a matrix, we negate each of its elements. 1 will be minus 1, 4 will become minus 4, negative of 0 is 0, and negative of minus 1 is 1. Are these two matrices equal? For two matrices to be equal, their orders have to be equal and their corresponding elements also have to be equal. The orders of A transpose and negative A are equal, but are the corresponding elements equal? 1 is not equal to minus 1. Even if one set of corresponding elements are not equal, we can say that the matrices are not equal. We don't need to check the rest. So A transpose and negative A are not equal. And hence, matrix A is not skew-symmetric. This tells us something interesting. I want you to focus on the diagonal elements of A. By diagonal, I mean the leading diagonal. Notice that the diagonal elements do not change for the transpose. 1 and minus 1, 1 and minus 1. And for negative A, just like the other elements, the elements in the diagonal are also negated. And what is the condition for a matrix to be a skew-symmetrical? It says that A transpose should be equal to negative A, which means all corresponding elements must be equal. Can the diagonal elements of these two matrices ever be equal? Let's say the diagonal elements of a matrix were 2 and 4. For A transpose, the diagonal elements would be 2 and 4, and for negative A, the diagonal elements would be minus 2 and minus 4, not equal. So if the diagonal elements are non-zero, the matrix can never be a skew-symmetric. Let's zoom out and write the condition. For the matrix to be skew-symmetric, the diagonal elements have to be 0. If the diagonal elements are non-zero, the matrix can never be skew-symmetric. Look at matrix B. Is it skew-symmetric? It is a square matrix and the leading diagonal elements are also 0. So it may be skew-symmetric. So let's find B transpose and negative B. Pause the video and try to find each. Okay, B transpose first. The first row will become the first column, 0, 2, and the second row will become the second column, minus 2, 0. And for minus B, we negate each element. Negative of 0 is 0, negative of 2 is minus 2, negative of minus 2 is 2, and negative of 0 is 0. Are these two matrices equal? Yes, the order as well as the corresponding elements are equal. So B is a skew-symmetric matrix. What about matrix C? Is it skew-symmetric? It is a square matrix and its leading diagonal elements are 0, so it may be a skew-symmetric matrix. We find C transpose first. The first row is written as the first column, and the second row is written as the second column. This is C transpose. And what about negative C? Each element when negated gives us this. The negative of 0 is 0, negative of 1 is -1, negative of 4 is -4, and the negative of 0 is 0. Clearly, these two matrices are not equal. Matrix C is not skew-symmetric.